Okay, so before we discuss the complex plane, it's important to really establish where the complex plane comes from. So far in mathematics, we've seen the real numbers, and the real numbers include in it, um, we have, we have rational numbers. These are the decimals and fractions, and a specific type of a rational number is an integer. Integers are all positive and negative, and also rational are positive and negative. And then inside the integers, we have the whole numbers. And really, I'm actually not going to go with whole numbers. I'm going to go with the natural numbers. Natural numbers are just all positive numbers. So these are like 1, 2, and so on forever. So positive numbers only. And then this is all considered rational numbers still. So a natural number is an integer is a rational number, and a rational number is a real number. Then we have a irrational number, which is a separate category. Irrational numbers are non-terminating, and no, I'm not saying it, so they're non-terminating and non-repeating decimal. And so this would be like pi e, or it would be a square root of a non-perfect square. So really quick, rational numbers also can have decimals that are, they either have to be terminating or non-repeating. So, or they have to be repeat forever. So it would be like 0.3 repeated, because that's really 1/3. So that's why that would be considered a rational number. And I just wanted to rewrite this so this is more neat. So all of this is then contained inside a new plane. And it's actually known as the complex plane. And it has numbers like I, and this is known as an imaginary number. So the entire concept here, oh, let me not forget the objective. It is, I can simplify square roots of negative numbers. So the entire concept of the complex plane stems from taking the square root of a negative number. So we define I as literally the square root of -1. So a pure imaginary number will be written in the form bi, where b is the real number and I is the imaginary part. So b would have been contained in the real number system, where I would have been the imaginary number. Okay, so this is where we simplify square roots of negative numbers. Okay, so this is really the same thing as, I'm going to write it in parentheses, -1 times 144, positive 144. So we're going to rewrite this as square root of -1 times the square root of 144. So this is a rule of radical numbers. This is literally just that. Negative 144 is the same as negative 1 times 144. Okay, so the square root of negative 1 is I. And then we're going to keep the square root of 144. And then we can take the square root of 144. That's going to be 12. And then you can rewrite like this, but really the more traditional way is to write 12i. Usually, just hold on. If you have a radical that is written like this, typically you write I in front of the radical. But when you then take the square root of the radical, you get I 2. You want to swap this. It's not the traditional way of writing it. So you do 2i. So it goes the real number, then imaginary. And this is important because in any textbook you look at, they're going to change the order and it will make sense why, because this is the more accepted way across the board. So here we have negative square root of negative 80. So I'm going to rewrite this as square root of negative 1 times 80. And then this is going to be the square root of negative 1 times square root of 80, which will be I square root of 80. So we're going to make a factor tree for 80. I already see 4 is part of it, and that's going to split it into 20, which is then going to split into 4 and 5. So 80 is going to be the same as, not sure why that paused, but 80 is the same as 5 times 4 squared is going to be 16. So I'm going to go back here. This will be I square root of 5 times 16. So then this is going to be I times square root of 5 times square root of 16, which will then be I times square root of 5 times 4, which will be 4I square root of 5. So as you see, it goes the real, then imaginary. Okay, actually, let me rephrase that. It goes the integer, or really the natural number, the imaginary number, and then the irrational number. We always put the irrational number last. Okay, so here we have the square root of negative 36 over 121. So this is technically in a parentheses, and it's really the same thing, because negative 36 over 121, when it's written like this, it's the same as negative 36 over 121. It's the same as 36 over negative 121. And it's even the same thing as negative 1 times just 36 over 121. So I'm going to rewrite this as the square root of negative 1 times 36 over 121. And then I'm going to separate the radical as square root of negative 1 times the square root of 36 over 121. Square root of negative 1 is I. Square root of 36 over 21 is technically the square root of 36 over the square root of 121. This is a 0.6 scale. And then we will rewrite this as I times 6 over 11. And technically, it's I over 1, because I divided by 1 is itself. So we will rewrite this as 6I over 11. My point is, do not put I in the denominator. Okay, so by the end of this video, you should be able to simplify square roots of negative numbers.